Contains duplicate. What if I told you that something as simple as checking for duplicates trips up more candidates than you'd expect, especially when speed and efficiency matter? Contains duplicate is a Pattern Mastery 100 classic, and it's a screening favorite at companies like Amazon and Apple. More than 50% of applicants try to brute force it. If you can nail this one, you're showing interviewers that you know your data structures and can think in real time. Let's see how pros do it. Let's break down the problem. You're given an array of integers, and you need to determine if any value appears at least twice. If any number shows up more than once, return true. Otherwise, return false. Super simple, but it tests your ability to spot the most efficient solution. Now let's assess our options. A brute force approach would check every pair, (n² time, but that's slow for big arrays. Instead, can we use a set to keep track of what we've seen as we scan the list? Sets in Python have O1 lookup time, so this lets us check for duplicates instantly as we go. This gives us an efficient ON time and ON space solution. Here's the structure of our plan. Create an empty set to store numbers we've seen. Loop through each number in the array. If the number is already in the set, return true, we found a duplicate. Otherwise, add the number to the set. If we finish the loop with no duplicates, return false. Let's try to implement it using solution 1. We're defining a function called contains_duplicate that takes an array nums. First, we sort the array in ascending order using a numeric sort, so values that are the same will end up next to each other. Now we loop through the array starting from index 1. At each position I, we compare the current value nums I with the previous value nums I, 1. If they are equal, that means we found a duplicate, so we immediately return true. If we finish the loop without finding any equal neighbors, then there are no duplicates, and we return false. Time complexity is O(n log n), because sorting takes n log n time. Space complexity is typically O1 to ON depending on the sorting implementation, but the key extra work here is sorting and a simple scan. Let's verify solution 1 for contains duplicate. Input is nums equals 1, 2, 3, 1. We sort the array, and it becomes 1, 1, 2, 3. Now we start checking adjacent values. At I equals 1, we compare nums 1, which is 1, with nums 0, which is also 1. They match, so we return true. The output is true, and the expected is true. They match, so solution 1 is correct for this test case. Let's try to implement it using solution 2. We're defining a function called contains_duplicate that takes an array nums. We create a set called scene to store numbers we've already encountered. Now we loop through the array from left to right. Inside the loop, we store the current value in a variable called num. We check if scene already contains num. If it does, that means we've seen this number before, so we immediately return true. If it doesn't, we add num to the set and continue. If we finish the loop without returning, then we never found a duplicate, so we return false. Time complexity is ON because we scan the array once. Space complexity is ON because the set can store up to n unique numbers. Let's verify solution 2 for contains duplicate. Input is nums equals 1, 2, 3, 4. We start with an empty set. At I equals 0, num is 1. 1 is not in the set, so we add 1. At I equals 1, num is 2. 2 is not in the set, so we add 2. At I equals 2, num is 3. 3 is not in the set, so we add 3. At I equals 3, num is 4. 4 is not in the set, so we add 4. We finish the loop, so we return false. The output is false, and the expected is false. They match, so solution 2 is correct for this test case. Let's recap contains duplicate. It's a quick problem, but it's a strong check on whether you can detect repetition efficiently instead of relying on slow comparisons. You're given a list of numbers, and the task is to determine whether any value appears more than once. Conceptually, this is about spotting duplicates without having to compare every number against every other number. We looked at the brute force idea of checking all pairs and saw why it doesn't scale well. Then we moved to optimize strategies, using a set for fast have we seen this before lookups, and also recognizing that sorting can work by placing equal values next to each other, though it adds extra overhead. The set-based plan is straightforward. Start with an empty set, scan through the array, and for each number, check whether it's already in the set. If it is, we immediately confirm a duplicate and return true. If not, we add it and continue. The sorting-based plan is also simple. Sort first, then scan once for any adjacent equal values. We implemented the solution and it ran successfully on LeetCode without errors, using a clean loop-driven process that checks values as they appear and returns as soon as a duplicate is detected. We confirmed correctness with LeetCode test cases. For 1, 2, 3, 1. The duplicate was detected and the result was true. For 1, 2, 3, 4, the scan completed without repeats and the result was false, matching the expected outputs. The takeaway is that data structure choice matters even in simple problems. A set turns duplicate detection into a fast, scalable one-pass process, and building that instinct, choosing the right tool for the job, is exactly what interviewers look for.